Have you ever rolled out a Power Platform solution only to dread the manual deployment chaos that follows? It doesn't have to be this way. Today, I'm walking through a step-by-step CI/CD setup using Azure DevOps, so you can stop firefighting deployment issues and actually move your projects forward. Ever wondered which variables, connections, and pipeline steps actually matter? Stick around. You'll finally see how to automate deployments without breaking a sweat. What actually goes into a Power Platform solution? If you've ever hit export on a Power Platform solution and then hesitated, wondering if you just forgot something critical, you're not alone. It's one of those moments where you expect to feel confident and organized, but then the doubts creep in. Did you pack up all those environment variables you painfully tracked down? Did that connection reference for your flow actually make it into the file, or is it waiting to sabotage your next import? These aren't academic fears. They're the day-to-day reality for anyone who's tried moving solutions between environments and found that export is only half the story. Even with Microsoft's improvements, it's rarely an all-in-one magic trick. Let's talk about what actually ends up inside a Power Platform solution file. And just as importantly, what doesn't. Because this confusion isn't just a minor detail, it's often the very thing that will decide if your pipeline works or unravels in production. Teams get a false sense of security from that exported zip. On paper, it's full of promise, but in practice, flows quietly break, apps throw strange errors, and half the configuration you expected to see just isn't there. Here's a classic scenario. A healthcare team spent weeks fine-tuning a patient intake app on their dev environment built out with everything from Dataverse tables to Power Automate flows. They exported the solution, breathed a sigh of relief, and moved it straight into test. Suddenly, nothing connected. Flows wouldn't trigger because connection references pointed to the wrong environment. Forms broke because environment variables for API URLs weren't set. After hours, lost. Retracing their steps, they realized those dependencies were never properly included or mapped. All the magic they built in dev just vaporized because the export didn't capture those moving parts. So what exactly lives inside a Power Platform solution package? At the core, you've got Dataverse tables, which act like the backbone for all your business data. Then you layer in Power Apps, both canvas and model-driven depending on your architecture. These define the face of what your users actually interact with day to day. Next, flows, the automated Power Automate processes that glue together APIs, approvals, and custom logic in the background. This is where it gets tricky. Environment variables, for example, are designed for things like API endpoints, credentials, or toggles that differ between dev, test, and production. They don't physically hold data. They're like placeholders that expect to be filled in once the solution lands in a new environment. Similarly, connection references are just pointers to external services, Outlook, SharePoint, SQL, you name it. When you export a solution, these references come along as empty shells. On import, they need to be reassociated with valid accounts and credentials in that target environment. If you skip this part or assume it'll just work, you're lining yourself up for those classic deployment headaches. This is why environment variables and connection references are not something you can set once and forget. They're dynamic. Teams evolve, authentication schemes change, and what worked last sprint might dead end next quarter. A Power Platform admin I know summed it up after a rough release window. Every time we missed a variable, support tickets spiked. Microsoft's internal telemetry backs this up, showing that deployment failures due to misconfigured variables or missing connection references are among the most reported issues with Power Platform solutions. Some surveys have shown nearly half of all solution deployment errors trace back to exactly these components. The structure of your solutions can seriously impact your pipeline's reliability. You might have all your components in one master solution, or maybe you separate out environments and apps by feature or team. Either way, consistency is what matters. If environment variables and connection references aren't tracked or named predictably, you end up sorting through a mess of mismatched settings every time you deploy. A sloppy solution structure means your pipeline spends more time resolving conflicts and less time moving your work forwards. So here's what you actually need to track. Beyond just the obvious tables, apps, and flows, you have to account for every environment variable used and every connection reference that your flows or apps depend on, because both will be empty or broken unless specifically mapped and configured at deployment. It sounds straightforward, but it often means going through each flow and Canvas app, checking which connections they use, and listing them side by side with your variables. Only then can you build a deployment pipeline that actually accounts for everything the solution needs to work. Knowing this upfront is the difference between a pipeline that calmly ships features and a system that falls over the second you leave the room. Before you even think about Azure DevOps or writing a single pipeline script, get that checklist tight. Your tables, your apps, your flows, and often, most important, every single environment variable and connection reference in use. This groundwork is what will decide how much you trust your automated deployments tomorrow. Now that we've got a handle on all the pieces that make or break a deployment, the next challenge is designing a pipeline that doesn't get tripped up by these dependencies. Because the reality is, knowing what to pack is only useful if you actually build the process to handle it step by step. Designing pipelines that don't fall apart. If you've ever watched your Azure DevOps pipeline grind to a halt on the second step, right after you are feeling good about your automated CI/CD setup, you know exactly how quickly optimism can turn into troubleshooting. A Power Platform pipeline can look impressive on paper, but when it hits production and lands in the wrong place, missing a variable or failing to connect to a service, that beautiful YAML script suddenly feels like a house of cards. So what sets apart a pipeline that quietly gets the job done from one that needs your constant babysitting? Most official documentation and a lot of blogs will show you a generic template that gets a solution from here to there, but let's be honest. Those samples skate right past the hard parts. You end up stitching together a YAML that looks fine until you realize there's a placeholder for environment name that nobody actually filled in. Dynamic variables not included. Secure connection management left out for simplicity. The result, pipelines that work in the training environment then immediately fail under the pressure of a real project with moving pieces and sensitive credentials. It's tempting to grab a sample YAML file and run with it thinking you can fill in the blanks later. I've done it. You've probably done it too. But Power Platform deployments have quirks that trip up most of those generic approaches. Neither the classic DevOps template nor a quick export-import fits the way apps, flows, and environment variables work in the real world. For Power Platform, standardization is a moving target. Connections change, variable scopes shift, and that one-size-fits-all sample quickly feels brittle. Many teams find themselves debugging cryptic errors after using copy-paste pipelines, only to discover later that their flows can't authenticate or that half the variables they need are missing or misconfigured. A regular DevOps pipeline designed for, say, a net app doesn't care about environment variables in the Power Platform sense or about connection references that must be remapped locally. Power Platform expects these details to be handled explicitly each time. It also expects certain permissions and for service connections to be provisioned against the right environments with the correct level of access. If you try to sidestep these specifics, even robust automation can break down fast. Getting service connections right is one of those things you don't realize is crucial until a deployment stops dead. In Azure DevOps, these service connections give your pipeline the authority to interact with Power Platform environments, importing solutions, running administration tasks, or updating variables. Misconfigure a service connection, for example, by scoping it to the wrong environment or neglecting permissions, and your deployment will hit a wall. Sometimes error messages are vague, just a failed step and an unauthorized warning that sends you hunting for missing permissions or expired tokens. The headache is real, and it almost always happens when you need a fast fix. Then there's the whole universe of pipeline variables. These aren't the environment variables inside your solution. They're variables that your Azure DevOps pipeline uses to make decisions, pass information, or hide sensitive values. Let's say you want to run the same pipeline in dev, test, and production, but with different endpoint URLs, feature toggles, or credentials. Without parameterized variables, you end up hard coding these values into every pipeline, or worse, in source control, making changes tedious and insecure. Sensitive credentials need special attention. You can store them as secure pipeline variables, but even better is to use Azure Key Vault and reference the secrets directly from your YAML script. That way, real credentials never touch your source repo, and rotation is as simple as updating the Key Vault entry. Miss this step and you'll inevitably face a release where a password change breaks connectivity, usually at exactly the wrong moment. Here's a real example that still stings. A finance team rolled out a carefully planned Power Platform pipeline, but overlooked the scope on several pipeline variables. They defined app URL as a global variable, forgetting that their dev and prod environments use different endpoints. During deployment to production, the flows silently failed because they kept trying to call the dev API. Logs only showed unauthorized access, not much help for troubleshooting. It turned out the prod pipeline was picking up the wrong variable, duplicating a classic human error because the YAML didn't support environment-specific scoping. If they built a variable matrix or parameterized their pipeline, none of this would have happened. A robust pipeline for Power Platform in Azure DevOps actually has a recognizable anatomy. You'll see distinct stages: build, test, deploy, each broken into jobs that manage logical tasks. Variables are declared at the right scope, some at the top, some inside specific stages, with secrets always securely referenced. Service connections are mapped to each environment, not just once at the global level. Everything critical for an environment, URLs, IDs, credentials, must be accounted for at the correct point in the process, so swapping environments doesn't require friction or risky edits. When you structure your Power Platform pipeline properly, clarity and maintainability follow. A new team member or future you a month from now can understand where variables live, how connection references flow through each step, and where secrets are stored safely. Instead of a spaghetti mess of YAML references and hidden gotchas, you end up with a clear step-by-step workflow that's much harder to accidentally break. With this kind of blueprint, you don't just automate, you create predictable, reliable pipelines that scale as your solutions grow, and you avoid the classic traps that so many teams fall into when they treat Power Platform the same as any other app. It's all about building with intention every step of the way. So with the foundation clear what your pipeline actually needs and how to keep it maintainable, the next move is to build out a working YAML script that pulls it all together step by step. This is where theory becomes practice and flexible automation finally takes shape. From theory to YAML, building a working pipeline script. If you've made it this far, you've probably hit that classic wall. Your brand new YAML pipeline looks great, at least until you point it at a different environment. Suddenly, what worked in dev throws unpredictable errors in test, or worse, drops into production and breaks features that users actually use. The real challenge isn't starting a pipeline, it's making one that doesn't care if it's running in dev, test, or prod. Translating all those well-made plans and must-haves into a working YAML pipeline is where most teams feel the friction. It's especially true in Power Platform, where environment variables, connections, and imports are less forgiving than in traditional app pipelines. Let's walk through what actually happens when you build a pipeline from scratch that's designed to survive all those moving parts. Most teams hit a brick wall when someone hard codes an environment variable inside the pipeline script. It seems easier, set prod.rel right in the YAML, put admin user next to it, and move on. Then 6 weeks later, business priorities shift, your org splits environments, and suddenly your so-called automation is just technical debt wearing a nice outfit. Hard-coded values force you back to the pipeline editor every time you need to change something. Even worse, hard coding credentials is just asking for compliance headaches or a secret leak in version control. The safest play is to parameterize everything that actually changes between environments. Pipeline parameters act as placeholders. So instead of setting API endpoint to a hard value, you give it a dynamic placeholder that's set when the pipeline runs. In Azure DevOps, you can define parameters both in your pipeline YAML and in your pipeline library. Let's say you need different Dataverse URLs or different API keys for each environment. You create a variable group, maybe linked to Azure Key Vault, then reference those variables in the pipeline script itself. With each deployment, the pipeline pulls the correct values for that environment, hands off secrets safely, and keeps sensitive info out of your code base. Secure values are a headache if you ignore them, but actually simple once you get the pattern down. The trick is leveraging Azure Key Vault. Instead of setting service principal password or custom API key in plain text, you store them as secrets. Azure DevOps can link directly to Key Vault, letting you pull those values at runtime. No plain text, no oops, committed a password again moments. You can even rotate credentials without touching your YAML. Just update Key Vault and the next pipeline run pulls the new value. This keeps auditors happy and your pipeline secure even as requirements change. Managing connections requires its own attention. Connection references in Power Platform don't move smoothly between environments. When your pipeline imports a solution, those references need to be mapped each time with real working credentials for that specific environment. Your YAML script must include steps to bind those connections after import. Typically, you include a set connection step that uses environment scoped variables to map each connection reference to the right resource. If your pipeline skips this, flows and apps will fail silently or loudly on the next run, causing more confusion than clarity. Here's the big picture of a typical Power Platform deployment pipeline in Azure DevOps. You usually see these stages. First, export your solution from the source environment. Second, store the exported solution as an artifact in the pipeline. Third, import the solution into the target environment. Those are the basics, but the magic's in the details. Before or after importing, the pipeline sets or validates environment variables. It then remaps each connection reference so everything works in its new home. The last step is validation, which isn't just optional QA, it's damage control. Many teams run smoke tests like triggering a flow or opening an app just to confirm the deployment actually did what it said it did. Adding automated tests to the pipeline is a huge step up from manual spot checks. If you can run sample data through a deployed solution or trigger a single test flow and check its result, you catch issues before users do. An automated smoke test in Azure DevOps can be as simple as a PowerShell task that calls a critical API or submits a form. If it fails, the pipeline can roll back or throw a clear error. You avoid late-night troubleshooting and panicked rollbacks. Here's a sample YAML snippet to illustrate this in action. YAML parameters: name, environment type, string default, dev variables, group, EPP solution variables, wow environment, name, connection reference, one value, terminals connection reference, one, steps, task, Power Platform, export solution, add 0, inputs, solution, name, my solution environment, URL, or source and URL, app hide, or service principal id, client secret, service principal secret, task, Power Platform, import solution, add 0, inputs, solution file, pipeline, workspace, exported my solution, zip environment URL, target URL, APAD, our service principal id client secret, our service principal secret, script, PBVH, our scripts, update envars PS1, env environment, pbash, scripts map connections, PS1, connection ref, connection reference 1, display name, set environment variables and map connections, task, PowerShell at 2 inputs, target type, inline, script, Nash run smoke test, Pish, scripts test app PS1 envo environment, display name, run smoke test. Each step here is parameterized. No hard-coded secrets with values from variable groups or key vault. The smoke test makes sure the deployment didn't quietly fail. Update envars PS1 and map connections.ps1 handle the problem areas, so there's no need to edit YAML every time your environment changes. Getting to this point means you've built a pipeline that adapts to change and guards against the most common deployment failures. It's clear, it's modular, and you can hand it to another admin without a crash course. But for all this automation, the next stumbling block is making sure your deployment is reversible and that failures don't become outages. So how do you keep things safe when even the best pipeline hits a snag? Keeping deployments safe, rollbacks, testing, and continuous improvement. When your new pipeline sails through testing and then hits production with a broken app, it's a reminder that even well-structured automation can bring down the house. The reality is, no matter how diligent you are about your YAML or how tight your variable management is, things slip through. A CI/CD pipeline doesn't guarantee perfection. In fact, it often brings bugs to production faster, just with more consistency. Plenty of teams skip over what happens when a deployment goes south, assuming it won't happen to us because we have automation. But even the best pipeline can introduce a minor tweak, a missing environment variable, a mismapped connection, or just a flow that doesn't trigger like you thought it would. And suddenly a small update has cascading effects on business processes. One team I worked with had a Power app that managed expense submissions. They rolled out a routine fix. The pipeline ran, everything lit up green, and then employees stopped getting approval notifications. It turned out a connection reference for Outlook shifted in the import, and their test didn't cover that exact scenario. With no way to roll back cleanly, they spent hours manually patching settings while frustrated messages flooded in. That's why a really robust pipeline always bakes in safeguards. Adding environment-specific testing is more than ticking a checkbox at the end of your pipeline. It's about putting your app through its paces after every deployment. You can build in validation flows, special test flows set up just to check, say, that critical emails actually send, that a connector still pulls data, or that a form on the new version really loads. These tests aren't just for show, they catch silent failures that can linger until users complain. Smoke tests are helpful because they're fast. After your import step, you plug in a PowerShell script or use a custom Power Automate flow to simulate a typical user action. For example, you can submit a dummy record or trigger the most important flow and check the outcome. The pipeline only moves forward if these smoke tests pass. If something's off, the deployment halts immediately. You can also set up your pipeline to notify you by Teams, email, or an Azure DevOps alert, so you're not refreshing the dashboard waiting for failures to appear. Automating rollback is another level entirely. Anyone who's sat through a failed release and wished for an undo button knows how it feels. Azure DevOps helps by letting you keep versioned artifacts of every solution package you've ever deployed. Instead of scrambling to export from a broken environment, you simply tell your pipeline to redeploy the previous package and restore the last known good state. The difference here is huge. Instead of firefighting and poking around in tables, you're running a controlled restore with just a few clicks or commands. Take a recent example from a logistics firm. Their Power Platform pipeline introduced a formatting change meant to clean up some views. Testing in dev and test environments passed, but production had a backend service with a stricter data contract. The import slipped through and critical dashboards went down. Thankfully, because every solution zip was stored as an artifact, the team pushed the rollback button, re-importing the last good build in under 10 minutes. They went from high-stress downtime to stable service, all before the morning shift logged in. Continuous monitoring makes this whole process proactive, not just reactive. Azure DevOps provides pipeline logs that record each variable, each service call, and the pass-fail status of test scripts. Combined with Power Platform Analytics, which spot API errors, missing connections, or slow-running flows, you start to see failure patterns before users complain. Reviewing this data after every deployment isn't about scorekeeping. It's about spotting silent issues. Those problems that don't bring systems down but gradually make apps unreliable. Every failed deployment handled right becomes a feedback loop. You don't just patch the solution. You go back through logs, study your pipeline results, and tweak the process. Sometimes that means expanding your smoke testing, sometimes adding a new rollback step, and sometimes changing how you scope variables so they don't overlap. The real payoff is that each trip up means the next release is that much smoother. Teams who treat failed releases as learning opportunities quickly end up with pipelines that almost never surprise them. By integrating environment-specific validation, automated rollback, and active monitoring, you build a deployment process that's both resilient and self-correcting. The process won't eliminate all risk, but it does give you guardrails so small errors don't turn into major disruptions. And the more you refine your CI/CD pipeline with lessons from real failures, the more confident you get releasing features quickly and safely. That's why deployment isn't just a technical task, it's a discipline. These habits, test, monitor, rollback, analyze, turn automation into a living process instead of a one-time project. The next step is tying all these lessons together so you can actually start knowing you've stacked the odds in your favor. Because even as tech changes and the Power Platform grows, the fundamentals of rock-solid release management never go out of style. Automation isn't just about removing manual effort, it's about creating a release process that people actually trust. When deployments move smoothly, teams stop worrying about what might break and start planning what could improve. If you're just starting out, take it slow, automate one piece of your process, see how it changes things, and build from there. Share your own wins or stories in the comments. There's always another lesson out there. We'll be diving deeper into advanced testing, real-world governance strategies, and even where AI tools are changing DevOps for Power Platform. So keep an eye out for what's next.